A few highlights from the Prepare for Class work for section 1.3. This here is the standard form of a linear equation. We recognize it's the standard form because I have two variables. A, B, and C are constants, two variables, and each of them are to the first power. So they're not squared or cubed or anything. They're just x to the 1 and y to the 1. One question was, what on earth is the use of this? Well, part of it is just to get us used to standardization, and we can recognize the type of equation or function or graph where graph of the equation that we would have if we recognize right away the type of function it is. And a lot of times in math we'll work with something in standard form. Note, different textbooks call different things standard form, and we'll address some of that later. But sometimes this is general form, where we've got the variables on one side, constant on the other. Capital letters usually indicate whole or integer numbers. They could be positive or negative. This is our old familiar y equals mx plus b. This is called slope-intercept form. M is the slope. The slope is, this is a delta, a little triangle symbol, the change in y over the change in x, which we also know as the rise over the run, which is also y2 minus y1 over x2 minus x1, where x is 1 point, x1, y1, and x2, y2 is the second point. So we can find the slope. B is the point 0b, or the y-intercept, or the value of y when x equals 0. This is also where the line crosses the x-axis. And then point slope form. Most students at this stage don't use the point slope form very often, but this is useful if we're given a point and a slope. That's where it comes from. The slope is m, the point is x1, y1, and x and y are our general x and y variables. Then we were asked specifically how to do question 4 from the Prepare for Class work. I've transcribed one version of it here. Differences were the weight and the rate of gain. So the weight of a newborn is 10.5 pounds. That's a very big baby. The baby gained 1/2 pound a month for the first year. And anyone who's raised a child knows that's not really realistic, but for this situation, that's what we're assuming. Find the linear function. Linear function, we haven't talked about functions yet in this class, but that's coming up next. Most of us know what a function is. We want to model the baby's weight, W, as a function of the age of the baby in months, T. So T is time. Weight is the weight of the baby. The slope is the average rate of change. Slope equals average rate of change. In a linear equation, that's a constant. And so the baby gained 1/2 pound a month. So the slope in this case equals 1/2 pound, or 1/2 pound a month. So the weight of the baby as a function of time is going to be 1/2 times time, or the age of the baby in months, plus the weight of the baby at time 0. The weight of the baby at time 0 is 10.5. W as a function of t, that's what this abbreviation means. Weight as a function of time, because they defined W up in our sentence and they find time, t, up in our sentence. Weight as a function of time is 1/2 pounds per month times the number of months plus 10.5, the weight of the baby at time 0. I hope this helps.